Hello, hello, hello. Good afternoon, Internet. Welcome. Welcome to day 39 of NL Math Man's Math Help Streams. We're back here on another wonderful Monday, and yeah, we're about ready to tuck into our math for the week. We're here in the background for me today now. We're back on the rock, right? We're back taking another little look at Green Gardens Trail, right? This is a picture from the very beginning of that. So I thought it was appropriate. Stream starts soon. Well, the hike was about to start soon in this picture as well. But before I get started, with my hike, I am finishing up today's lunch here, as and I thought, well, again, maybe I'll show a little bit of this show food, right? It doesn't look, whoa, boy, hmm, maybe I'll go over and use this other cam, right? I mean, it looks kind of haggard, right? There's not much left of it there now. But that is some very nice chili that I made the weekend with broke out one of the packs of dried beans that's in the cupboard, soaked it overnight. Um, got some cans of tomatoes, right? Now, when I use canned tomatoes, I like to use canned whole tomatoes. I used to even just use crushed tomatoes, right? But I find like when whole tomatoes break down, the texture and the thickness that you get is just far and away beyond anything. It's just the perfect texture for tomato sauce or anything tomato based, right? So I like to start it French style, with a nice mirepoix with some carrot, onion, and celery. Cook that down in butter till it's nice and soft. Then throw in the whole tomatoes, get them to cook down. Some bay leaves and then some chili spices. Cook those for a bit. Add the beans. Boy, oh boy, mm, it's a real treat. It's one of my best dishes for sure. I've made chili a bunch of times. And the recipe has evolved a lot over the course of when I've made chili. You know, I use stock in it as well. This has chicken stock, of course. Almost always use chicken stock in chili. But there's been a lot of changes, a lot of evolutions to it over the time. But I would say that uh, it's one of the best recipes I learned, and I'm pretty proud of a lot of the chilies that I've made. I would say, and my current recipe is better than ever, right? But anyway, you know, came here to learn about math. But first, I am going to show a little bit more about this trail here because I do want to talk about that. Show another few vistas from it. Seeing, you know, we're going to do a little bit of adventuring at the beginning of my streams for a few minutes before I, tuck into the math work. See here, this shot of Green Gardens is um, just past the spot where you begin, right? Just the parking lot, right? So you go for about, I don't know, a solid few kilometers on terrain that looks kind of like this, right? Fairly flat. Behind us, if you could turn around 180 degrees and look the other direction, you'd see the massive tablelands just sort of towering in the distance there, which are a mountain that's made from the Earth's mantle that was pushed to the surface, right? Because Newfoundland is actually, as an island, is comprised of parts of three different um, geological plates that are all crammed together, right? And part of what happened when the plates crammed together, they pushed up the tablelands. You can see some of the orangish rock that the tablelands are comprised of. They're around my feet as I'm walking there now, right? But you don't actually see the tablelands themselves; those are behind us, and they're gigantic, right? And they're like mostly bereft of life, right? Which is a great phrase. Um, it's hard to judge distance over the tablelands. You look at it, and it doesn't look anything like what it's going to like the distance is going to actually be when you start walking. Let me tell you. Maybe I'll show some pics of that at some point as well. That'd be a fun one to talk about for a few minutes before stream. So we see after the first little while that looked like that last picture, we end up walking on down winding through a forested path. I believe I showed a picture of this part only recently as well, just a few minutes ago. Or a few minutes ago? A few streams ago. Boy. Um, and then after going down through all this, you are really rewarded next to the campsite, right? Oh, okay. We can see carrying on across the path here. But like I was saying, after you get down through all this path, you come down, do that first barren part down over the hill, come right along, and then you see across, a vista that looks kind of like this, right? Which is it's pretty amazing. I'm currently in this picture standing on top of like a small flight of stairs that goes down, but you can see how sheer these cliffs are. And the rest site that myself and my father stayed at is actually not far away from that bright red cliff that's over there. You can see it in like sort of like the middle, sort of down below the STA in Starts. Right, there's a fairly steep red cliff. That is where one of the rest sites is, right on top of that. So yeah, the views are incredible from a lot of different angles. It's a really, really beautiful hike. And yeah, I'd love to be back out at it this year, but we'll see. We'll see how that all shakes out. But for today now, I do have a bit of math to get to. Not quite as much as some days. Um, we're getting into the end of the month here now, and yeah, people are preparing to write tests. Let me tell you, there's two more testing days for the end of the month for my students, Tuesday and Thursday. So any tests that are completed Thursday should be able to be in for the month because, of course, the month reports are in on Friday. So Wednesday will be the absolute last day to submit course material, and then Thursday you'll be able to do tests only if all the course material has been submitted on Wednesday. And I ain't gonna deal with people submitting at like 9 p.m. Wednesday. It's got to be submitted before close of class Wednesday. So like before 3 p.m. Then we'll be able to write the test Thursday and then get that one in for the month, right? But now tomorrow I've got 7 people on the list now to write tests for tomorrow already. We'll see how many more I have before the end of the day. But yeah, we're tearing through. We're getting her done, right? Now for today, I don't have, like I said, I don't have as much to go through as I do some days, because I guess people are busy studying and prepping and getting ready for their tests tomorrow. First, I'm going to do some stuff on drawing Venn diagrams. I'm going to walk down through. This is going to be from sections 1.3 and 1.4 of Math 3101A. I've got 5 or 6 questions I want to get to on those just to show off some of the different things that we're going to be doing with Venn diagrams in that unit. Then surface area of regular 3D shapes. We've talked about this several times, right? But that's not to say that I'm like, oh, you should already know because we talked about it several times. It's just, it goes to show how important a topic it is that it keeps coming up and it's in a lot of different courses. And yeah, we look at it in a lot of different angles. So from the, but overall, yeah, it's a really important topic, and I am going to spend a little bit more time today talking about that one. But first, like I said, we're going to go over and I'm going to do Math 3101A and I'm going to do some Venn diagrams. So let's go on over here. So this is going to be Math 101A, and then this is going to be Unit 1. Okay. So over here, we see on the side, like I'm looking at page, let's see, what page of the textbook is it? Calais? This will be 31. So I'm looking at page 31 of the textbook here now just to summarize some of the key ideas that we're talking about in this unit thus far. It says the union of two or more sets, for example, AUB, or a union of A and B, consists of all the elements that are in at least one of the sets, right? So I often refer to this one as A or B, like we talked about, right? Because it's any of the element that's in either in set A or in set B goes into this, excuse me. Is represented by the entire region of these sets on a Venn diagram, is indicated by the word or, like it says here, right? So the next one, the intersection, two or more sets, A and B, consists of all the elements that are common to these sets, right? So these are only the intersection, right? So when we talk about A or B, it's anything that's here, anything that's here. When we talk about A and B, that's this little bit that's here. Now, I've talked about these ones before, but one reason I want to bring this up today is because of this bit down here, which we didn't really talk about specifically yet. And this one is what they call the exclusion principle, right? principle of inclusion and exclusion, excuse me. To calculate so the number of A or B, we subtract the elements in the intersection so they are not counted twice. All right? So this is a super important thing to know. And this is, like I said, page 36. This is the principle of inclusion and exclusion, like so. Right? So what that tells us is the number of elements that are in A or B is equal to the number of elements in A plus the number of elements in B, subtract the number of elements that are in A and B both. Now, why do we have to do that, right? But it's because, like say for example, let me do, I'll do number of A in green, and I'll do number of B in red, and then we'll see number of A and B. We'll kind of see what happens, right? So let's go do A. This is A over here. This is B over here, right? So if I was to draw sort of just some hatching, some shading there for all the elements of A, we see that it looks roughly like that, right? Those are all the elements of A. Now if I do the same thing, I do some sort of hatching and some elements of B, I'm going to do them in a different direction so it's a little bit clearer that it's different, right? So here now, right, if I was to count all the green and all the red, right, if I was to add all the green and all the red, the middle part, this part in here, that would be added twice, right? That's why we need to subtract the number of A and B. Now, like I was saying, it's really, really important to remember this. It's fairly straightforward once you realize that you had to do it, but from the start, it's not always super intuitive to know that you have to go ahead and you had to subtract these to sort of to discount for this part in the middle here, right? Um, Now, this is not what the questions that we're going to do today are directly on, but you'll see as we go through that this sort of principle is extremely important in all the questions that we will be doing. All right, I'm going to move on to page, see, that was page 31, sorry, not page 36, 31. So I'm going to move on now to page, let's see, 34 in your textbook. Here we go. Page 34, and I'm going to do a few of these questions. Right? I'm going to start off with the top one of the page here, number 12. Okay? So this is now going to be page 34, and then question 12. Question 12 we see over on the side here says, at a retirement home, red sky night, sailors delight, red sky in the morning, sailors take warning. That's true. That's good. Yes, thank you. Right, so this picture behind me, here right now, yeah, like Albert Einstein has informed us, if this picture was taken at night, that'd be great. But if it was taken in the morning, oh boy, there's a storm coming. It's true. Right, I believe I'm 99% certain this was a sunset picture. Because, like, when in the world would I ever have seen a sunrise, right? Like, you'd have to be up at like 5 in the morning for that. What is this nonsense? No, it definitely was a sunset picture. So for question 12, like I said, at a retirement home, 100 seniors were interviewed. 16 like to watch television and listen to the radio. 67 like to watch television. Determine how many seniors prefer to listen to the radio only. Right? Well, how do we figure out ones like that? Basically, what we're always going to do for questions like this, first up, we're going to draw out our Venn diagram. with our circles, like this and like that, right? So now I'm going to have, what do we have? Television. So this one's going to be TV. This one's going to be radio over here, right? So we know that 16 like to watch television and listen to the radio. Now, one of the important things that we're going to do when we're doing questions like this is we're always going to start with the middlemost ones that we can, right? It's always important to start with the overlap. And it's because of this up here, right? So we know we have to have 16 in here. Then 67 like to watch television, right? So right now, I might be tempted to go and just put a 67 in here, right? But that's wrong. I can't do that, right? Because okay, so if I put 67 in for TV, right? Because that seems to make sense from what we've read, right? But if I put 67 in for TV, the total number of people watching TV would actually be 67 plus 16, which is 83. And that's too many, right? Because we weren't told to use 67. So what we have to do here is actually 67 minus 16. So this is going to be 51, right? So we know that the number in here for TV is going to be 51. So 51 people here, 16 people here. And we're told that 100 seniors were interviewed in total, right? So now, based on this exclusion principle, we can go sort of fill stuff in, right? We know that the number of TV or radio has got to equal 100, right? Because we were told that from the question. So this means then that, well, we also know that the number of TV or radio has got to equal the number of TV plus the number of radio, subtract the number of TV and radio, right? So we know that that's got to be the case. I'm slanting again because of the angle that I'm sitting at. So here now we know that this is 100, right? The number of TV is 51. The number of radio is our unknown. We're going to call this X because this is the one we're figuring out. And then subtract 16, right? So now what I'm going to do is just sort of move these ones around, right? So 100 is going to equal 35. Well, actually, no. No, this is not really how we would go about doing this one now, is it? This is the number of, sorry, the X wouldn't actually be in there. This is the number of radio, right? So then 65 is equal to X, which is equal to the number of radio, right? So we know now that determine how many people prefer to listen to the radio only. Okay, but that's not what they were asking. This, what I figured out now, is not what goes in here. The 65 doesn't go in here. What goes in here is a little bit easier, right? Because this is true. What I found out here, this was the number of people that listened to the radio in total, right? It's 65. But that's not the number that goes in there. The number that goes in there is going to be, we could call that 100 minus 16 and minus 51, right? Which is going to be 100 minus 67, which is going to be 33, right? That's right, isn't it? I think so. Yeah, of course it is. So we know that this one here is going to be 33 people. Okay? And this is the number of radio and not TV. What in the world does that mean? Right? So this is one of the reasons I wanted to do questions like this also is to show this kind of thing, right? So what does this notation mean? It's a little bit more of a complicated way of referring to these ones, but you are going to see questions just like this later on, where this is 33 is a number of radio and not TV, which is to say just this number over here, right? It's a number that's in radio, but also not in the TV. Okay, let's try number 16 here. I think I can fit this one onto this page. So Beyonce, I don't know who Beyonce. That's like one worse than Beyonce, right? Because there's C and then D. So Beyonce. Uh, Beyonce solved the following problem. A total of 48 students were asked how they got to school. 31 students drive a car, 16 students take a bus, 12 students do not drive a car or take a bus. Some students drive a car or take a bus. Hmm? Oh, they could do either. Okay, so there are some overlap. But yeah, but they wouldn't be and because that'd be a bit of a weird way of phrasing it, wouldn't be? Wouldn't it be? Yeah, they drive a car and take a bus. Well, I guess they could do partly one and partly the other. But it means and in the sense that sometimes they drive a car, sometimes they take a bus. Okay, that makes sense. So what we're going to have then for this situation, I'm going to draw my two circles out like this for my Venn diagram, right? So this one's going to be car over here, and this one's going to be bus over here, right? Now we're told that 12 students do not drive a car or take a bus. They don't do either. So 12 are going to be here on the outside in our universal set, right? Because they don't do either. We can fill that in first. We know 31 drive a car, 16 take a bus, and some number do both. Now this is the real meat of what I wanted to show for these ones. Okay, so Calais, I think this is the kind of ones that you were asking for. And then after this one, I'm going to get into some that are a little bit more involved, but on the same topic still. Because we don't know the number of both. I'm going to call that X, right? Because I don't know how many are in this overlap. There's some, though, but I don't know how many. Now, car in total, so 31 students drive a car, right? But that means that between this sort of C-shaped section out here and this oval section, or rather for the whole car circle, that's got to make 31. So in here, I'm going to call this 31 subtract x. Because whatever value this one out here is 31 less that much, because these two have to add together to make 31. Same deal over here with the bus ones, right? So now I see that 16 take a bus, so it's going to be 16 minus x is how many are going to be over here in this section. Okay? And a total of 48 students were asked how they got to school. Well, now I know that this part, plus this part, plus this part, plus this, plus the outside part in the universal set, that has the total number of students that went, right? So the total number of students that were surveyed were 48. So I know that 48 is going to equal 31 minus x plus 16 minus x plus 12 over here, right? Oh, there we go, or plus 12. So now I can go through and I can simplify this a bit, right? So I have 48. I'm just going to leave the 48 on the left, and I'm going to simplify the right as much as I can. So I've got 31 plus 16 is going to be 47. 47 plus a further 12 is going to be 59. So it's 59, and then I've got a negative x here, a negative x here, and a positive x here. So it's going to be two negative x's and one positive x, makes a negative x there. So now, yeah, you might already see what the answer is here for our overlap part, but I'm just going to go through and finish it, right? So I'm going to call this x equals 59 minus 48. Then we know that x is equal to 11. Right? So we know now that how many students do not take a bus to school? Okay. Well, now I can go back and I can fill in, right? So now that I have this x equals 11, I'm going to circle that in blue. Now I can go back and fill this in. right? So 16 minus 11 is going to equal 5 in this category. This category here is going to be 11. And this one over here is going to be 31 minus 11 equals 20 in this category, right? So now, because I've gone through and figured out what x is, I can go back and substitute that in. Excuse me. So determine how many students do not take a bus to school. So the number of not bus is going to equal 20 there, and 11 there is going to be 31. Right? Because the number of, sorry. The number of not bus, no, what am I doing? The number of not, boy, the number of not bus is going to be everything outside of this circle here of bus, right? So the numbers that are bus are 11 and 5, right? Because these ones sometimes take the bus, these ones always take the bus. But these 20 over here, they never take the bus, and these 12 out here, they never take the bus. So it's 32. 32 students are going to be the number of people that never take the bus. And now, this question also asks us another bit that we sometimes had to get onto in these questions, where it says, where it gives us a solution and then asks us, why is that solution wrong? So Bionde said that 15 students drive a car but do not take a bus. 12 students do neither, so 27 students do not take a bus. Is Bionde correct? Well, no. Right? The total of three numbers is 59, so the region for the students who take a bus overlaps the region through a Venn diagram. The problem there, right, is that Bionde's diagram, the way it's drawn, does not account for the fact that some students take a bus but do not take a car. You notice the way that this Venn diagram over here is drawn? There's no B section by itself. The B section only exists within C over here. But we know that's not the case, right? We know that there are some students who take a bus but do not sometimes take a car. So that's why, in general, you should start off drawing your Venn diagrams like this, so that there's a region of overlap and then a region for both of them by themselves as well. Let's pop over and do some questions that are a bit more like the ones that you will see, say, on your test or on your assignments. Right? So I'm going to skip on over here now. I'm going to skip to page 52, which we can see over here now on the side. So this is going to be Math 3101A Unit 1 still. Okay? And this is going to be, let's see, do I want to do page 50? Oh, I wanted to do page 51 first. Yeah, okay. So on page 51, I'm going to do question 4. Okay, let me zoom in a little bit over here so we can see question 4 with a bit more detail. Yeah, here we go. So Jennifer is an optician. She's trying to decide whether she should offer a package deal to customers who buy glasses and contact lenses. She hires a survey company to research customer preferences. A survey of 641 people provides the following information. Well, that survey company is working pretty hard. They did a survey of, got 641 respondents for just one client like that. In a lot of surveys and stuff you see, right? Like 1,000 people is considered to be like a very thorough sort of representative sample, right? So 641 for just one optician who wanted to know. Boy, this company is working for their money, let me tell you. But anyway, so a survey of 641 people provides the following information. 83 wear contact lenses, 442 wear glasses, 167 do not use corrective lenses at all. So what percentage of Jennifer's customers might use a package deal and use set notation in your answer? Okay. So our first step is always going to be to draw out a Venn diagram like I've been doing. Right? So I'll draw this one fairly big so that we can have a bit of room to work with here. So that wasn't quite as big as I hoped. So contact lenses. and then glasses. I'll just use C and G for the rest of those. Contact lenses and glasses. 83 wear contacts, 442 wear glasses, and 167 don't use any corrective lenses whatsoever. So the question then is, how much overlap are we going to have? Now, from the start, of course, we don't know the amount of overlap that we have. So we're going to call that overlap X, right? That's an unknown amount in the center. Then for contacts, what we know that the full circle of contacts has to make 83. If the full circle of contacts has to make 83, whatever's out here is 83, subtract this bit. So that's what we write in. 83 minus X. That's what's over there. Same deal over here, right? 442 makes this full glasses circle. So this part out here has to be 442, subtract what's in there. So this is going to be 442 minus X. There, like so. Right? And we know that outside in the universal set, we have 167. 167 of our customers that don't use any corrective lenses whatsoever. Right? So then we know that when we get to our full total is 641. So our 641, the full number, is going to have to be the same as all these four added together, right? So the 641 is going to be 167 plus 83 minus X plus 442 minus X. So 641 is going to equal 167 plus 83 plus 442. It's going to be 692. And then there's one negative X here, one negative X here, and one positive X here. So these two are going to cancel. We're going to be left with a negative X. So 641 equals 692 subtract X. So then X is going to equal 692 subtract 641. And we're going to see that X is going to equal 51. Right? Now that we know this, we can go and substitute that back in up here. Right? So we know that I'll put it in a different color. Yeah. I'll put it in green. So this is going to be 51. So I'm going to circle that in green. I'm going to go back and put those in up here. So this is 51 now. This is 442 minus 51, which is going to be 391. Yep. Like I say, never be too proud to check your arithmetic. Then 83, this one's going to be 83 minus 51, which is going to equal 22, right? 32. See? Almost needed to check my arithmetic then. It's like I'm saying. Don't be too proud to check. Anyway, so what was the question? The question was, what percent of Jennifer's customers might use a package deal? Okay, well, that's asking us what percent of her customers use both glasses and corrective lenses, because that's what they mean by a package deal, right? Multiple ones of them combined together. So we know that 51 are the overlap, right? So the percent right? So just a reminder, right? Because it's not really what this course is on per se. To find a number as a percent of another, we're going to divide and then multiply by 100, right? So here, we're going to be doing 51 divide by, her total was, what was that, 641? So 51 over 641 is going to equal 0.0796, and I'll say that's about 8%, right? Because we're going to multiply that by 100 to get the percent. So about 8%. And just to model how to write it out correctly, like we're going to be doing, right? So that would say about 8% of Jennifer's customers might use a package deal. They're like so. Okay? I said use set notation in your answer. I didn't actually really use set notation in my answer now, did I? But to use set notation, we could say that, so this equals the number of contacts and glasses, right? To use set notation here. Okay. Now, I also wanted to do two more questions on this topic. I'm going to go to the next page and do question 6. Because some of these ones, Calais, as you will see on your activities and tests and stuff, frequently we're going to be involving 3 circles in our Venn diagrams and not just 2, right? So I'm going to go on and do question 6 next. That one tells us a total of 58 teens attended a sports camp that trained in at least one of 3 sports: swimming, cycling, and running. 35 in swimming, 32 in cycling, 38 in running. 9 in swimming and cycling, but not in running. 11 cycling and running, but not swimming. 13 swimming and running, but not cycling. Triathlon consists of all 3. How many teens might be training for the upcoming triathlon? Yeesh. Boy, oh boy. That question has a lot going on. So, but the amount that is going on is pretty similar to a lot of the questions that you're going to see, like I've said, right? So we're going to go and we're going to do a 3 Venn diagram, 3 circle Venn diagram, sort of like this. This one is swimming, this one is cycling, and this one is running down here, right? And we always start at the center as much as we can. Whenever we're filling in a Venn diagram like this, start at the center, right? So we're going to call this one X here because we don't know. We don't know how many are in the center because it doesn't tell us how many like to do all 3, right? Now it does tell us trained in swimming and cycling, but not in running, right? So where is that section, right? So let me actually over here. Let's do out everything that we know. This is a good way of writing this out. This will show you some set notation as well. So this is good, killing 2 birds with 1 stone. So the number of swimming is going to equal 35. The number of cycling is going to equal 32. The number of running is going to equal 38. We were told that. But then 9 trained in swimming and cycling, but not in running. How do we write that out? Well, 9 trained in swimming and cycling and not running. This is how we write that out. Swimming and cycling and not running. Right? And that number is 9. So we're going to go ahead and keep writing down the rest of these ones. This one is cycling and running and not swimming. That one is 11. And then the number of swimming and running but not cycling, swimming and running and not cycling, that one is going to be 13. Right? But what it's asking us for then is the number of all 3 that's here right in the center. Now, we don't know that one yet, but we can now go and figure and fill these ones in. Because swimming and cycling and not running, well, where is that? Where's the part of this diagram that has swimming and cycling but doesn't have running? Well, it's going to be this bit here, right? This bit. Because this is both in swimming and it's in cycling, but it's not in running. So we know this one here is 9. So the next one, C and R, but not S, that's going to be over here. That one's going to be 11. And this one over here is going to be 13. So we know those 3, right? But now, what value is going to go out here? Right? What values are going to go here, here, and here? How in the world can we figure those out? Right? Well, we know that the full circle of swimming is 35, don't we? Right? We know that this full thing, that one's going to make 35. So I'm going to do these in different colors so you can see that I'm sort of filling them in afterwards. So we know that 35 subtract Um, so the number, actually, yeah, let me fill it in this way. The number of swimming and not cycling and not running, so just swimming, right? We know that that is going to be, I didn't really give myself enough room over here on the side, so let me just carry on down below. That's going to equal 35, subtract 9, subtract 13, and subtract x. So that's going to equal, it's going to be another 13, right? So I know now that 13 minus x has to go over here. And why is that? Right? Well, because 13 plus 9 plus 13 gets us back to this original 35. So we know that there has to be 13 between this bit that's out here, just the S part, and this unknown bit in the center. Those two together have to make the 13 to get us back to this one, right? And it's sort of the same deal for, say, the number of cycling and not swimming and not running. That's going to equal 32 minus 9 minus 11 and minus x. So that's going to be 12 minus x. So then 12 minus x has to go over here, right? And we know that, like I said, right, because there's 32 in total for this full circle of C. So there's 9 and 11 here, so there's 20 of them already accounted for. So then there's 12 left over to split between this bit that we haven't accounted for and this bit in the middle that we're trying to find out. And it's going to be sort of the same deal for the other one, right? So the number of running and not swimming and not cycling is going to be 38 minus 13 minus 11 and minus x, which is going to be the same as 14 minus x. They're like so, right? So we know that 14 minus x goes over here. So now we know that 58 are in total, right? So we know that the total are 58, right? So once we've got this figured out, and this looks like a lot of work that we've done so far, but really at this point now, the question is pretty much done, right? Because now we know that 58 is going to equal all of these added together once. It's going to get us back to our original 58. So now I can go through and fill it in, right? 13 minus x plus 9, and I'm just going to go sort of counterclockwise, plus 12 minus x, sorry, counterclockwise? Clockwise. Um, plus 11 plus 14 minus x plus 13 plus x, right? So I just sort of went like whoop, in a circular sort of pattern, right? Anyway, it doesn't matter the order you write them down because addition is commutative, which means that the order actually doesn't matter. So because we're adding all these together, as long as you're getting them written incorrectly and have them all there once, you'll be good to go. $72, right? So I added together all the constants, so the 13, the 9, the 12, the 11, the 14, and the 13, right? That made 72. And then we have a negative x here, a negative x here, a negative x here, yep, and a positive x here. So that's three negative x's and one positive x. So we're going to be left with a negative 2x. And now once we've got this, all of a sudden, hey, this is a fairly straightforward algebra question like we've seen loads and loads and loads of times. So now we're going to call this 2x equals 72 minus 58. 2x equals 2x equals 14, right? So then x is going to equal 7. There we go. So now that we know that x equals 7, how many teams might be training for the upcoming triathlon? So we can call this the number of S and C and R equals 7. 7 teams. 17s might be training for the triathlon. There we go. So I'm going to do one more, Calais, from this unit, and then I'll yeah, have a few questions for another unit, and then yeah, like I said, this might be a tiny bit shorter than normal today, but we're getting up there. We're getting up there back to normal time frame. So this is Math 3101A Unit 1 still. And I'm going to go down now, and I'm going to do, oh, skipped. Going to do question 9 here. Page 52, question 9. John was asked to solve the following problem. 240 students were surveyed to determine which restaurants they like. Okay. 90 like chicken and more, 90 like fast pizza, 90 like gigantic burger. Okay. Seems like those places are equally popular. 37 like chicken and more and fast pizza, but not gigantic burger. 19 like chicken and more and gigantic burger, but not fast pizza. 11 like fast pizza and gigantic burger, but not chicken and more. And 13 like all three of them. How many students do not like any of the restaurants? Well, you will see questions very, very similar to this one, which is why I wanted to do this one, because it's a little bit of a different take on that, what that last one was like. But I'm still going to go ahead and I'm going to start off with 3 circles in my Venn diagram here. I'm going to get, this time I'm actually going to do nice and large circles. There we go. Good. Okay, so I'm going to call this one chicken and more. I'm going to call this one fast pizza. And I'm going to call this one gigantic burger. Okay? Now, when we start writing, we might be tempted to start writing in the order that the book tells them to us, right? But that's a trap. Because math teachers are sneaky, right? That's one of the main lessons for my Twitch stream. Math teachers are sneaky. Or teachers are sneaky in general, right? We always try to throw a little bit of a curveball at you. You don't go ahead and start writing these out in the order that they're written, or you're going to get it wrong, right? But we know that the number of CM, if I list it over here, what we know the number of CM is 90. We know the number of fast pizza is 90, and we know the number of gigantic burger is 90. We were told that. We were told that the number of chicken and more and F fast pizza and not gigantic burger, we were told that that number is 37. The number of chicken and more and gigantic burger and not fast pizza, we were told that that one is 19. And then the number of fast pizza and gigantic burger and not chicken and more was 11. But we were also told that the number of all three is going to be 13. Okay, one reason I really wanted to do this question is because this is a super common one. You're going to see ones like this on your assignment and on your test that ask effectively exactly the same thing that this one is asking. And the mistake that John made, we'll get to in a second, but that's a common one that you're going to see in a situation like this. But we know that we always are supposed to start filling in from the middle. Always start filling in from the middle, like so, right? So we know the number of all three of them, it's going to be 13 in there, right? So then we were told, because the number of all three of them put together is 13. Now we've got these ones here, say the number of fast pizza and gigantic burger and not chicken and more is 11. So where is that? So fast pizza and gigantic burger, but not chicken and more. So that's going to be this over here. Do I just plug in an 11 here? Like that? Hmm. Yes, for this case. Oh, right. Okay. Never mind. I was getting ahead of myself. I thought this one was a bit trickier than it was going to be. But yes, that is exactly what we do. We plug in just an 11 over here like that. I was I was preparing. You could see from what I was saying that I was preparing to be like, no, there's a curveball here. But that's actually not in this question. I will show you one, not today, but I will show you one where there is a curveball in that type of thing as well. But for here, it's not, right? Because we know that fast pizza and gigantic burger and not chicken and more is just this arc here, right? And that one is 11. So chicken and more and gigantic burger and not fast pizza. So chicken and more and gigantic burger and not fast pizza. That's this section over here. That one's going to be 19. And then the other one, chicken and more and fast pizza, but not gigantic burger. That one is 37. So there's a lot of overlap between those two guys, right? But now, how do we fill in these other three? How indeed. Well, we know that we have, right? So the number of CM, we know that that's 90, right? So we know that 90 is going to equal 37, because all these ones put together are going to equal 90, right? So that 90 is going to equal 37 plus 13 plus 19 plus some unknown number, right? So 90 is going to be, well, 13 plus 37 is 50. 50 and 19 is 69. 69 plus x. So it's going to be 90 minus 69 is going to equal x. So it's going to be 21 equals x. So we know that over here, people that just like chicken and more, we know that one here has got to be 21. And it's going to be the same deal for the other two as well, right? So we know that the number of fast pizza is also 90. So that 90 is going to equal 37 plus 13 plus 11 plus x, right? So 90 is going to equal, well, 37 and 13 still makes 50, and then that's going to be 61 equals x. So 90 minus 61 equals x, or 29. So we know that 29 are going to be over here, just like in fast pizza, right? And I think you can probably see where I'm going with this. The number of Great Britain, or gigantic burger, that's going to be 90, right? So we know now that 90 is going to be 19 plus 13 plus 11 plus x. There, like that. So 19 plus 11 is 30, is 43. So 90 is going to be 43 plus x. 90 minus 43 equals x. So that's going to be 47 equals x. So there's now a 47 there, right? So are we done? Are we finished? Well, it says how many students do not like any of these restaurants? Well, what do we how are we going to figure that out? Well, that's going to be the amount that was sort of left over outside, right? The amount of people that are left outside there. We were told from the start that 240 students were surveyed. So we know that the number total is going to be 240, right? We were told that. So we know now that this plus all these numbers added together, there has to be another one out here that gets us up to our total of 240, right? So now we know that, that 240 is going to equal 21 plus 37 plus 29, right? Plus 19 plus 13 plus 11 and plus 47, and then plus x. And x in this case is going to be the ones that are outside, right? The leftovers. The students who didn't like any of these. Boy, calling them the leftovers, but that's a bit rude. 21 plus 37 plus 29 plus 19 plus 13 plus 11 plus 47 So 240 equals 177 plus x, right? So 240 minus 177 is going to be 63. So then 63 equals x. So we know then 63 students 63 students did not like either restaurant. Okay? So what was John's mistake? What mistake did John make here that we see? So John added up the first 6 results of the survey and subtracted the number of students who ate at all 3 restaurants. Then subtracted this value from the total number of students surveyed and found that negative 84 students didn't like either restaurant. Right? But of course here, John just added those 90s together, didn't he? 90, 90, and 90. But the thing is, 90, 90, and 90 together, that would already be 270 people. That's already way too many, right? He simply didn't account for the fact that 90 is the total number that like chicken and more. So any overlapping people, they sort of subtract from the 90, right? What he missed was the first thing that I talked about today, which was the exclusion principle, right? What John ended up doing was he didn't even just count people twice, he counted some people 3 times. So the fact that he counted people multiple times is what gave him a total that's way higher than what it should have been. Right? So Calais, that is that's a look at some of the questions you were asking about. I hope that answered it fairly well. Let me go back over here to my intro screen. Tell you what, let's put this one back on. Yeah, that's a nice shot. It's a nice action shot. So that was drawing Venn diagrams, determining subsets, finding unknown values. Yep, we exhaustively covered that one, I think. It was nearly an hour on that. Then surface area of regular 3D shapes. Yeah, let's do a little bit of those. I'm only going to do a few of them just to sort of show how it's done, because I did do this review, this exact sheet a little bit recently. But, I'll do it again, just like Goofy in the meme, right? I'll do it again. There's always different students doing these ones, and it is, like I keep saying, this one's a super important topic. So let's pop over to this view here. This is now going to be Math 1102A, Unit. This is Unit 3. Yes, Unit 3. So we know now that we have to use the formula for the surface area of a cylinder, right? It can be tempting sometimes to just, not tempting, but it's an easy mistake to make to use the wrong formula. Excuse me. So we have to remember which one is the surface area. And the surface area of it is given to you on the sheet. You just have to be careful to use the SA one, not the V, right? Because the V one is the volume. But the surface area of a cylinder is 2 pi r squared plus 2 pi r h. That's what it always is, right? And like we've talked about before, this term here gets us the top and the bottom. This term here gets us the sides. Right? So I'm just going to go through and do I guess 2 of these out fairly quickly to show you how we're going to go about doing these guys. Right? So for this one now, we're told that our radius is equal to 4 inches and our height is equal to 10. Right? So now we're just going to go through and fill this in. Surface area is equal to 2 pi 4 squared, because we were given it as the radius. We don't even need to change that. Plus 2 pi 4 and 10. Right? So the surface area there is going to be 4 squared is 16, so it's going to be 32 pies. So this one over here is going to be 80 pies. Right? 2 times 4 is 8. 8 times 10 is 80. Then we're going to add these two together. Surface area is going to be 112 pi. And I'm going to go through and put that in my calculator. 112 times pi. It's going to be 351.9. 351.9 square inches. It's going to be squared, right? Because it's surface area. Area is how much space something takes up. Let's see here. Why is this going so slowly? Okay. Now I'm going to do, this is question 7. Let's go do that one down here, down below. Right, it's going to be the same surface area formula. Surface area is going to be 2 pi r squared plus 2 pi r h, like so, right? We know that here diameter is equal to 10, so our radius is equal to 5, and we know that height is equal to 10. So now, once we've got those, we can just go back and fill it in, right? So our surface area is going to equal 2 pi 5 squared plus 2 pi 5 and 10. So 5 squared is 25. 2 times 25 is 50. So it's 50 pi plus, it's going to be 50 times 2 is 100. 100 pi. So the surface area is going to be 150 times pi. So the surface area is going to be 471.2. Yeah, now that seeing I'm at it, let's do 6 and 8 as well, and then that should be plenty. To zoom out a touch for this one. There we go. So number 6, we still have our same formula. Surface area is equal to 2 pi r squared plus 2 pi r h, like that. Here now we're told that our diameter is equal to 32 centimeters, therefore our radius is going to be 16 centimeters, and our height is 11 centimeters. So now we go back and fill it in. 2 pi 16 squared plus 2 pi 16 and 11. Surface area is equal to, I should know 16 squared off the top of my head, 250, of course, 256. How did I, oh my goodness, of all the numbers not to remember. 512 pi plus 32 times 352, 352 pi. So the surface area is going to be 864 pi. So the surface area then is going to be 2714.3. That is centimeters squared. All right, now I'm going to go down to number 8 down here. Surface area still 2 pi r squared plus 2 pi r h. I like to always write my formula out every time. Right? Seems a bit crazy, I know, but you know, I find it really helps memorize these kind of things. So then the radius is going to be 1.5 feet, right? The height is going to be 4 feet. So we're going to have surface area is going to equal 2 times pi times 1.5 squared plus 2 times pi times 1.5 times 4. 2 times 2, it should be 4.5. Right, 1.5 squared is 2.25 times 2 is, of course, 4.5. So this is 4.5 pi plus 2 times 1.5 is, of course, 3. 3 times 4 is 12 plus 12 pi. So surface area is equal to 16.5 pi, which is going to be, surface area is going to be 51.8 feet squared. And there we go. There we go. That was, yeah, those are fairly quick. Rattle those ones off. But those are the ones that Renetta, I think you needed me to go over. So hopefully that will be useful to you as well. Right? I think you are currently working on another sort of activity on this same topic. Um, and Renetta, I believe you. Let's see. Now you might be a little bit off doing your test tomorrow, but you should definitely. I think you'll be ready for it Thursday. I imagine. Right. Okay. And then Thursday will still get you the course for the month to complete your course on Thursday, right? So just to recap again what I said earlier about tests for anyone who watches this now or in the future, probably mostly in the future. Um, yeah, the Thursday is going to be our final day for testing for this month, of course, because Friday is the last class day of this month. But you'll only be able to write a test on Thursday if you've got all your work in before we say before noon on the previous day. That's to give us enough time to correct. Yeah, before noon on Wednesday. Might If you only got a little bit, might be able to push past noon, but ideally you'll get it in like middle of the day Wednesday in order to make sure that'll be the end of your coursework. Then you'll be able to do your test on Thursday, then to get your credit in for the month for Friday, right? But yeah, I've got a lot of students writing tests tomorrow. So again, probably quite a few of those students are diligently studying now. Is my sincerest hope because I've got 7 doing tests tomorrow morning. So it's gonna be a busy day tomorrow. Um, if you are one of those students, please remember to confirm that you are going to take your test. I will be asking you to confirm tomorrow morning as well, so that I don't end up sending a test to somebody who at the last minute had to cancel and wasn't able or didn't think to tell me. Either way, yeah, that is going to be my stream for today. I hope it's been useful and entertaining and engaging and all that. Um, as always, let me know if you have any other questions about any of your work. And yep, stay safe. And I hope to see you, well, hear from you again for tomorrow. Right? Thanks.